My first bench rest build is well underway. In this video, we're going to talk about stock work. Gavin here from UltimateReloader.com. This is the start of my very first bench rest rifle build. In the last video, the first part of the series, I talked about the barreled action and specifically the barrel work. We've got a BAT Model B octagonal bench rest receiver here with integral Picatinny rail and integral recoil lug. We started with a 27-inch Krieger 6.5 1 1/8 twist 4-groove barrel blank that ended up to be 26 inches. I cut a target crown. Couple things were different about this build, including cutting a cone breech, which you'll find in a non-repeater. This is my first non-repeater build. Used the true bore alignment system on the Precision Matthews lathe. I used the SSG range rods from Straight Shot Gunsmithing to dial in the muzzle end to cut that crown. If you want to know more about that story, you're going to want to check out that first video. What we have here is the Wheeler Accuracy LRB stock. This is manufactured by Macmillan Composites, Macmillan Fiberglass. I wanted to go with this stock because of the 4-inch forend. This has kind of an integrated bag rider design here on the front. The straight profile on the bottom of the buttstock, and then we've got this steerable rudder where we can completely dial in the tracking of the rifle in the front and rear rests to make sure that we don't have any kind of deviation from perfect, absolute, straight ahead shooting on that. In this video, I'm going to talk about all of the stock work up to, but not including the paint work. That's going to be in the next video. So we're going to be cutting the barrel channel. We're going to be performing all the inletting, doing the bedding, and then making some specialty cuts to finish some things off. So I'm going to go get the mill set up. I'm going to start the process, and I'll be back to guide you through what I'm doing with this stock step by step. So here we are a month later and the stock work is done. Things turned out great, and I'm going to walk through each of the steps step by step. This is not an instructional video. I don't do instructional videos the first time I go through a process. That is a recipe for disaster. A couple things. I want to thank 3 people for their help. Alex Wheeler from Wheeler Accuracy, Daryl Tom, and Bruce Tom from Bat Machine. These guys have done this kind of work many times. I didn't have a bench rest stock to look at here in the shop, and this is my first time with a bunch of these different types of procedures and processes. Done a bunch of bedding jobs. This is a totally different animal here. So thank you guys for your help getting this done. Also to note, all of the work here was done with the Precision Matthews PM 949 TV milling machine. This thing is a beast. It's awesome. It's totally accurate, and it did a super job. I've got a 3-axis DRO. This kind of a package you can do just about anything you need to do. Slower and more meticulous than CNC, but definitely very capable and flexible. So the first thing I did was to do a bunch of research, figure out what the process needed to look like step by step, take a bunch of measurements, get some specifications like length of pull from Wheeler Accuracy, and then figure out exactly where things needed to be positioned and what kind of clearances I was going to need. The length of pull establishes the fore-aft positioning of the barrel action in the stock, and then getting the tang of the receiver flush with the back of the stock where it slopes here by the grip is going to establish your vertical. And usually you want your bolt stop to be a little bit below the waterline, the top of the stock here, and it could be halfway, it could be a little bit less than halfway. Mine ended up a little bit less than halfway to make this tang flush back here. And then I took a bunch of measurements and cross-checked those with Bat Machine, for instance. Things like the spacing for everything, the overall length, the thickness of the recoil lug, the action screw spacing, the front trigger guard screw spacing. You've got to build a plan, and you've got to be confident with that plan. And once you do that, you're ready to start cutting. So I already talked about the mill. Let's talk about the primary cutting tools that I used for this job. There's 2 that are somewhat specialty here, and then there's one that's fairly typical. This is a core box cutter. This is essentially a router bit. This is 1 3/8 inch. That was per Alex Wheeler's recommendation. Also from Alex recommended is a compression bit. This is more or less a router bit. What it does is it pulls the chips towards each other so that you don't have ripping effects and jagged edges, that kind of thing. That was used for most of the clearancing after the core box cutter was used. And then I also used a double-ended 5/8 inch end mill. This is with square ends. And unfortunately, this is a dull end mill, and that caused a little bit of problems. That was used to cut the recess for the trigger guard. So I've also got a long 1/4 inch end mill here that I used for the trigger mortise. So I also used some drill bits, obviously, and things like that, but these are kind of the primary specialty cutting tools that you're going to need to use with your mill for this kind of work. So the first step, after getting the rifle stock positioned in the middle, it was positioned more or less like this. The fore end was clamped in the milling vise, and then I had a hold down clamp on the butt stock. What's critical here? It's critical to get it perfectly straight this way, to make sure that it's not tilted, and to make sure that it's level this way. I took quite a while taking multiple measurements to ensure that everything was perfectly good there. Then you want to establish your center line. And what I did for that was I took readings with an edge finder on either side of the bag rider feature here on the fore end. And then I also took similar readings on the outside of the stock on either side, and I established my y-axis 0. This is where your cutter is perfectly on the center line. I used that same 0 for pretty much all of the initial operations. Super critical to get that right and to monitor things once you start cutting. And the first cutting step was to cut the barrel channel. And it's not just the barrel channel. So keep in mind the barrel channel is essentially narrower than the receiver inlet for this particular configuration. So you can go ahead and run your barrel channel all the way back to the majority of your receiver inletting. I left the rear tang area alone at that point. I didn't even go back that far because I knew I was going to have to use an end mill to mill out that pocket so that it would fit flush in the bedding. And I was a little bit conservative with the depth. I had an idea of where the depth on this barrel channel inlet needed to be, knowing that I could fix that and go a little bit deeper a little later once the receiver was sitting down in the stock. So at this point, you've got your initial channel cut. Then it's time to start the receiver inletting operations on the mill. After the barrel channel is cut, we move over to the receiver area, and we're going to do the inletting job there. It gets a little bit more complicated at this point. Here I've got an octagonal receiver, so we've got sloped sides, we've got a flat bottom, and then we've got straight sides along each outer side of the receiver itself. And that means I'm not going to try and cut that profile exactly. We know that our epoxy from our bedding job will come in, it'll flow, and it'll fill all that up. So my goal was to have about 50 thousandths air gap around the critical areas and to cut accordingly. I started with this core box cutter and cut it to the calculated required depth, and then I actually made side cuts to widen that channel a little bit so that I would have 50 thousandths clearance. But that left me with a radius side, so I came with this 3/8 inch compression bit and made side straight cuts so that I knew that I would have allowance for these straight flats coming down and a little bit beyond that, because again the epoxy will flow. After that, I cut the Tang Pocket. This was with the 3/8 inch compression bit. I established what my cut needed to be at the very back. I had sloped the sides after that with blue tape. So I came up to where it was the straight section. I went back to the pocket mill and I just ran a line of blue tape down there, leaving about 50 thousandths. So then I progressed to inch the table in this direction along the x-axis and then just continue to mill back and forth until I hit the blue tape. Not totally precision oriented, and it doesn't have to be because we're filling that with epoxy. After the Tang Pocket was cut, we come to the Recoil Lug Pocket and we cut that. Got to get fairly close to the sides here so that you have plenty of clearance for that recoil lug surface. And what I did was I left about 25 to 30 thousandths for the epoxy to flow between where the recoil lug will sit and where the pocket was cut. That way you have a perfect contact area for the recoil lug. Lots of attention to detail. At this point, once you've got all of those steps done, you can actually take the barreled action and set it down in the stock to see how things are going to fit, see if things look right. After this, we can talk about making and installing our pillars. You can buy pillars for bedding actions, but why buy pillars when you can make exactly what you want on your lathe? I chose to do that. For the front, I made a flanged pillar, so it's got a flange on the bottom. It's going to sit on the bottom of the fiberglass and provide more contact area. And then in the rear, I just did a cylindrical pillar. Both turned out to be 1/2 inch diameter, so I used 1/2 inch material, 1/2 inch aluminum round bar for the rear, and then I used 3/4 for the front and cut basically the OD down and then created a 1/2 inch projection, left the flange, turned it around, got everything set up and left clearance for the action screws. The action screws are 1/4 inch, so I left, I believe, about 25 thousandths extra clearance so that those action screws have an air gap. Very important to only have the recoil lug taking the recoil. You don't want any touching between the action screws and those pillars on the inside. And after the pillars were made, I had grooved them with glue grooves so that I could glue them in and have a little bit of a mechanical interface between the glue and the pillar. I used 5-minute epoxy, pushed them into place, and very carefully positioned the rear pillar vertically so that the action would sit on the rear pillar. When I talk about bedding, we'll talk about how I supported the barrel as well. Made sure that the ejection port was perfectly level with the water line. Pillars are done. So now that you've checked, double checked, and triple checked, everything is fitting perfectly, we can go on to the process of bedding. And I've completely documented this whole process. And if you click on that first link in the video description, you can read through all of these notes. Again, not an instructional video per se, but I wanted to chronicle what I did here. So the first thing I did was a trick that I learned from Daryl Tom from Bat Machine, and that is to take a piece of plastic pipe, to cut it along one side so it's a split sleeve, and to slide it up onto the barrel. This is a tapered barrel, which is your friend here, because we can slide it up until it's supported evenly. Front is supported with that split sleeve. The rear is supported by the rear pillar, which I tapped to just the right height when I had glued it in with that 5-minute epoxy. Checked alignment, actually with digital calipers here at the front to make sure my gap was even. I had studs. These are 1/4 inch screws that are excessively long that I had screwed in. I actually taped them with blue tape so that they would fit with the friction fit. Everything was perfect, perfect air gap all around after we removed the tape, perfect spacing. Okay, good to go. Now it's time to mix epoxy, and this is where things started to go sideways. This is the first time I'm using DevCon, which is aluminum powdered and resin epoxy compound. This is from the folks at Bat Machine again. It flows really good. It has a long set time. It's great stuff. But my scale somehow had a jammed button or something, because after I had added the powdered aluminum compound, I went to add hardener and the scale display was not changing at all. This thing goes down to 1/1000th of a pound, at least indicated. And so I'm panicking at this point. I'm like, okay, it's 9-to-1 by weight. What do I do here? So I kept adding the resin until I thought it looked like maybe it weighs 9-to-1, maybe. And I started to mix it, and I'm getting worked up at this point. I'm like, oh crap, if I put too much in, it might harden too quickly. If I don't put enough in, I'm going to be scraping out peanut butter in a few days. This is not where I wanted to be. I had a plan and I was trying hard, but it was stressing me out. But things got worse. So I treated the receiver inlet as a gravy boat essentially and dumped the epoxy in there. I followed my instructions from Daryl Tom. I got my heat gun out and I popped the bubbles. They rise to the top with heat. I'm thinking, okay, this is looking good. I had put plugs of clay in each of the action screw holes in the pillars. I was going to push the studs through, no leakage. I did that, and nothing oozed up out of the sides. I didn't put enough epoxy in. Moral of the story, put it all in. Doesn't matter how much it is, just put it all in. So I had to pull the barrel to action out. It's covered with epoxy. I didn't have anywhere to put it, so I'm holding it between my legs over the garbage can. It's dripping into the garbage can. This is really not what I want at this point. I'm flaming mad. I just can't believe it. I've tried so hard and things are just going so wrong. So I scraped the rest of the epoxy from the bowl, I put it in the receiver, and I proceed to slap, well, gently set the barrel to action back. It's starting to drip through the pillar holes. This is just, it's a disaster. And so I did my best. I set it there, and then I waited 3 hours, again, per Daryl's instructions, to come back and scrape off the excess, because it gets like hard peanut butter, essentially, very workable. You want to get that excess off so you don't have to break things apart and do excessive sanding and filing. And where I had certain cuts, like for the Recoil Lug Pocket, things had started to droop, so the next morning I actually added more epoxy, leveled it up to the top, got things looking good. Whew, waited until later in the day, and then was the moment of truth. This is the moment when you find out if stuff is royally messed up or if it worked. So I pulled on the barrel gently. I'm working it, I'm feeling it pop loose, and I lifted it up expecting to see air voids, pockets, and random crap, and it looked nearly perfect. I absolutely could not believe it. I think I started laughing. I'm thinking to myself, how did that work out? That was the closest I've ever come to a complete disaster and had near perfection. Yay, this is good. So, bedding complete. At that point, we could talk about profiling for the various features around the receiver. The profiling activities for the top of the stock involved 3 different cuts. First was the bolt handle notch. What I did was I angled the stock at about a 45-degree angle using these angle blocks to hold on to the bottom profile in the top corner of the stock. That actually was really solid, and I'm taking very, very light cuts. Again, I'm using the 3/8" compression bit here. I had to move the table along the x-axis a little bit to widen it to the specification I wanted. I like generous clearance. I don't like things to be running back and forth right next to a very tight tolerance. I don't know why, I just don't like that. And then on the other side, there's the load port, and then there's the bolt stop. You can run your profile for the load port right along the outward edge. I chose to drop it down a little bit. Now, I don't know if that's going to be optimal. There's less of a wide shelf here now for rounds to roll into the receiver on, so we'll have to see how that works. The bolt stop, again, I had a little bit of a profile below it. I don't like it to hug too tight, probably about 0.1 inch of air gap there. At this point, we can flip the stock upside down and cut the recess for the trigger guard. Now this is where I used this 5/8" double-ended end mill. Grandpa's end mill, dull, not good for cutting fiberglass, splintering all over the place. So I had to cut it just a little bit wider, and then you're going to trim the rear pillar down flush. And what I found was the stock is angled, and so I angled the stock a little bit in the mill. By the time I got it cut, it was a little bit too deep. So I did what a lot of guys do, actually, regardless of what the cut looks like, and that's to epoxy bed the trigger guard into the stock, and that gives you a really, really clean interface. And I was able to push the trigger guard down until it was perfectly flush with the bottom of the stock. I left it slightly proud because I'm going to have the thickness of the primer and the paint down there. And that really is the majority of the inletting work. When you're done cutting the trigger guard recess, you can drill out the front screw hole for the trigger guard. The action screw is on the rear, and you've got your separate screw for the front of the trigger guard that goes all the way up into the action on this BAT Model B. And at that point, you can basically do a test fit of everything. I installed the trigger on the barreled action. I put my bolt stop back in. I installed the bolt, put the trigger guard on. I did have to shorten the screws for the front of the trigger guard and the rear action screw. So what I did was I took a depth measurement relative to the stock, which is the top of the trigger guard, and then I gave myself 20 thousandths air gap inside those blind holes. Put the screws on the lathe, pushing them through a 5C collet. Got my DRO zeroed on an end. You can basically shorten an action screw by the thousandth of an inch. Everything fit together perfectly, everything bolted together nicely, and oh my word, this Bix and Andy trigger, you can breathe on it and it'll go off. So that is the process of doing all of the stock work for this particular build. It has been a tremendous learning experience. It's been an exercise in patience, and again, I really appreciate the folks over at Bat Machine and Wheeler Accuracy. Next, I'm going to talk about the paint process, and this is one that is near and dear to me because in high school I went out and got a job at a body shop and learned auto body work and auto paint work, all the way up to doing complete paint jobs. So I love this kind of thing. Wait till you guys see what the paint job is gonna look like. It feels like I'm on the downhill slope. After that, of course, we're gonna break in the barrel, we're gonna do some shooting, we're gonna check out 6.5x47 in a bench rest gun, and a whole bunch of other stuff. So thank you for watching. If there's anything that you'd like to say regard to your particular bench rest rifle and stock that you're working with, drop a comment and let's start a discussion. That concludes this video. That means it's time to wrap it up. I hope you liked this video. If you did, please give it a big thumbs up. Also, make your voice heard. If you have something to say, please drop a comment. Make sure you're subscribed with notifications because you're not going to want to miss the awesome content that is coming up. And finally, flex your reloading pride. You could look great in one of these t-shirts. We've got multiple designs at the Ultimate Reloader store. I'll see you later because I'm off to go shooting.